Text encoding and internationalization. So there are many languages around the world. English is not the only language in the world, although it is the most used language if we consider both first and second languages. As of 2016, Ethnologue cataloged 7,097 living human languages, but 389 of them account for 94% of the world's populations. Some of the largest languages based on native speakers is Mandarin Chinese, Spanish, English, Portuguese, Arabic, Hindi, and some others, as you see on the list here. And we should know that all language, all human natural language needs to be encoded to the computer binary system. All language needs encoding. Kind of write this here, all language needs encoding. English had, might have been the first one, which was the standard one, had the encoding called ASCII, American Standard Code for Information Interchange. And this is still in use today, and it is a 7-bit character encoding standard with 128 valid codes. So it ranges from these numbers right here, includes in binary, includes alphabets, upper and lower cases, digits, punctuations, common symbols, control characters. It worked relatively well for English typewriting. So if you notice here, these are all the values that can be translated to binary data. And so, for example, the hashtag symbol is represented as 1100, and then we got to go over here 010, 11001010. That's the binary form for the hashtag. If you want the capital A, as we saw before, it's 1000 001, and lowercase a is different, it's another. But of course, you can also create other rules for the computer to say that, well, if you have uppercase a or lowercase a, then treat them the same if one wishes to do so. Notice also there are digit numbers here encoded in binary as from the ASCII, which is 9 is 10011110. Now, this is not the same as actually recording the binary, the integer number in the computer in the integer format. So this is character type of data, and we talked about data type here, I hope, in previous lectures. So English has had the ASCII encoding system for a while, and it worked relatively well for English typewriting for a while. Now, there are all kinds of other characters you may have noted that are actually not in the system here because it's for English. So for example, as we just saw, the accent E with an accent like this, that's not represented in ASCII. Other diacritics or these symbols on the letters, naive, and the C with the little symbol on the bottom, like for the word facade. So, and of course, all other kinds of alphabets over there were not encoded in the ASCII, and not even other symbols that we have nowadays, such as emojis. Although we could make an emoji with the parentheses and the colon, of course, of ASCII. There are many also family of alphabets in the world, although the Latin alphabet makes up a large majority, and then the Chinese, and then Devanagari alphabet. This is just kind of some interesting information about the alphabet. So the alphabets will share some or most of the actual symbols of the language. And here the Latin includes the English, but also other from European languages, which have those extra symbols. But of course, Arabic and Chinese are entirely different alphabets. And there have been other encoding mechanisms developed for these other languages, IBM, EBCD, IC, Japanese, Chinese character code, and so on. But really the big one that actually works for many of these other languages as well is the Unicode and UTF-8. So you can see a share of web pages with different encodings, and this is across the world. UTF-8 was when it was developed, it kind of really became very dominant. So it's a kind of standard that everybody's using. And UTF-8 is one type of Unicode. So Unicode is the industry standard for encoding representing text. It has over 128,000 characters available. So if you remember, ASCII was only 128 valid characters. This Unicode enables 128,000, and it enables over 130 plus scripts and symbol sets. Can be implemented by different character endings. UTF-8, UTF-16, UTF-32. It's kind of well, we'll mostly focus on UTF-8, but it can actually be expanded. So Unicode refers to all of these different kinds of UTFs. And UTF is Unicode Transformational Format. It's generally 8 bits. So if you see the 8, but it has a variable length. So it can actually be extended to 1 or to 4 bytes. Each byte is 8 bits. So it's very useful in the sense of given this flexibility. And it's also backward compatible with ASCII. So the first byte, the first 8 bits actually codes the same as ASCII. So you can use all those same encoding, and different machines and different programs can understand UTF-8. Can understand ASCII if it's using UTF-8. So that's also very useful. It is the dominant character encoding for the web. And in Python, it's kind of default by Python, and Python renders it kind of automatically. In Python 2, it's a little bit more complicated, and I'll show you here some of the differences. So let's see an example regarding the word resume. So in Python 2, let's say we have the word, the value resume, and we put into a variable, and then we show the length of this text. And usually when we say have a length of a word, it would count the number of letters. So here's 1, 2, 3, 4, 5, 6, but somehow it says 8. And if you actually print it out, you see there's these extra characters here. And we may have seen some of this in the previous work we have done. And so when you break out item by item in text 1, you will see that there's these extra characters here. So for the E with an accent, you have this E symbol, and then this is probably the accent. Because here we see, well, we see it again, the same accent and the same E. So it needs kind of 2 additional elements to represent this E with the accent. The U you see in the front here refers to Unicode. So when you translate that to Unicode, you may still see the E with the accent. I'm sorry, you may still see the background. You may see a different kind of character and not actually print the E with the accent, even though it's in Unicode. So you really got to be careful with the encoding and what's kind of going on in the background of how texts are being represented. In Python 3, the E with the accent is already immediately represented in Unicode, and it's also rendered as we see it. In Python 2, even if you translate to Unicode, you still might see some of these funky symbols there, but at least it kind of better interprets this in Unicode format. The point really to take here is that every time we're working with text, when you upload some text from wherever source you're getting your text from, sometimes you just type it out, sometimes you're loading it from another file. We want to make sure how this text is rendered. We want to know what's the encoding that was used to render that text. And once we upload it, sometimes you just say encoding, encoding equals UTF-8, and that may work, but the text was not actually encoded in UTF-8, so some characters are going to be sort of messed up. So always break down your text in the smallest elements to make sure you actually have the correct encoding as you wish. So some take-home concepts, we have diversity in text and languages around the world. ASCII and other character encodings are popular, and we often want to handle text in UTF-8 encoding. That's it for this one. See you next time.